what we have done so far, we have illustrated that all complete unimodal maps have a monotone segment going up, a critical point, and monotone segment going down. And we saw the critical point was very important because its pre-iterates told us where the monotone segments will be for the iterations of the map. So this enabled us to go from unimodal map to map with 2 laps up, 2 laps down, or 4 laps up, and 2 to the n laps going up and down. One thing that's really important to understand is that the critical value is fixed, but the critical point can be a point or an interval. This is easiest to understand when you study repellers. So here I've drawn a repelling map. So you can think of this as some parabola which is just slightly higher than the ceiling. So what this map has, it has 3 intervals. It has a monotone interval going up, just like we did it before with unimodal maps. It has a monotone interval going down. What this interval does is it stretches part of the initial state space and maps it onto entire state space. Then there is an interval which takes part of the state space and maps it onto entire state space, but flipped, so the left end goes up and the right end goes down. And then there is an interval, which I'll denote by letter C, standing for critical, and it's an interval. And the crucial thing is that in this interval, if I start any point in that interval, its value is larger than 1. If I iterate this map, it'll just walk off to infinity. So this is a wandering point. It's not of interest to us because it has no recurrent dynamics at all. And we're interested in things that stay there for a long time. So a general partition of unimodal map is in 3 parts. There is a part which is monotone up, part that's monotone down, and then there's a third part which you can think of as a hole in a golf course or something. So if you have a golf course, you have a hill or the top, there's some, thing where you can get the ball right in the hole. You lost it. But if you go to the left, you go this way, and you miss it, you go to the right, you go the other way on the hill, and that's what these 2 branches signify. So this is very easy to understand for repellers. And that's why the canonical example of symbolic dynamics we use in Kerouac's book to motivate it is the 3-disc repelling set. Because what happens with 3 discs is you're here, you look out, you see 2 discs and a hole between them and a hole on the sides. And the hole between is this one, and hole on the sides is also of the map. And I'm only interested in hitting the disc. And that in one iteration there will be some kind of curve like this, which we explicitly constructed by looking at the phase space and finding a strip of initial points in phase space that hit the disk. So that's easy to understand. What seems to be harder to understand is that if the map goes below, it's again true that this can be an interval.